We're in section 8.2 where we're solving systems using matrices. So we've already seen how to solve a system of equations, a system of linear equations, by using substitution or elimination. That method does become clunky when we're dealing with maybe 3 or more equations with 3 or more variables. So we'll use a matrix and use our calculator to apply transformations to that matrix so that the solution just kind of falls out. So here's the way we do that. Start with the system of equations, the system of linear equations that you would like to solve. And first make sure that each equation is in standard form. So what that means is all of the terms involving variables, here I've got x, y, and z, all on one side of the equal sign and the number, the constant part, on the other. And then you want to make sure that they're all in the same order. So I've got x, y, and z. So for each one of these equations, x is first, and then y, and then z. Then what we do is we construct the augmented coefficient matrix. And this is what the matrix looks like for this particular system. Notice that inside the matrix, a matrix is just a rectangular array of numbers. You know, here I've got 3 rows and 1, 2, 3, 4 columns, which corresponds to my 3 equations. And then here's my 3 variables plus the augmented constant part. That's the 4th column there. Anyways, notice the very first row corresponds to all of the coefficients of the first equation. 8x, negative 1y, 2z equals 30. So I've got 8, negative 1, 2, 30. The next row has all the coefficients from the second equation in order, x, y, z, and then the constant term. And then the third row, 1, 2, negative 1, negative 6, are all the coefficients from the third equation. Okay, so notice when it says augmented, that's talking about this this column right here, that these are all the coefficients. Here's my x coefficients, y coefficients, z coefficients, and this is what it's equal to. All right, what we'll do is we're going to perform some operations on this matrix to get it into what's called reduced row echelon form. And what that looks like, I'll just show you down here. Reduced row echelon form is going to look like you've got 1s down the diagonal, 0 everywhere else, and then the augmented part has some numbers in it. So the non-augmented part just looks like 1s down the diagonal, 0 everywhere else. So that's what we would like, that's our goal. And the procedures that the transformations that we apply to the matrix is a lot like the transformations we apply when we're doing solving by elimination. You can multiply a row, that's like multiplying both sides of an equation by any number, multiply or divide. You can add any 2 rows together, subtract any 2 rows. So it's just like the elimination method, except for the calculator is going to do all of that work for you. Okay, so first thing we're going to do is input this matrix into our calculator. The steps are all listed here, so we'll just march through them. First thing we need to do is access the matrix menu. So on my TI-83, it's right here. It's above the x inverse, or x to the negative 1 button. So I get it by pressing second and pressing that button. And then notice here I've got 3 options: the names of my matrices, some math operations I can do on those matrices, and then I can edit the matrices. So I'm going to go over to edit, and I would like to enter in all these numbers here. So first we start, this is in step 2 now, we'll want to enter in the dimensions of the matrix. It goes rows and then columns. So the first number is the number of rows. I've got 3 rows, so you hit the number 3 and then enter to move to the number of columns. In my case, it's 4. And then notice that the calculator will highlight all the different entries in the matrix. It'll go across the row. So I'll put in all these numbers here. 8, enter. -1, enter, 2, enter, 30, enter. And then it'll go to the second row. -3, 4, enter, 5, enter. And then -20. Then it'll go to the last row. 1, 2, -1, -6. All right, now that you've got all the matrix entered into the calculator, you'll go ahead and exit out of here. So I'll hit second and then mode to kind of quit the matrix screen. All right, that was step 3. Now notice that the matrix should be stored in my calculator, and I put it in as matrix A. I could have, let me just go back here. I just chose the first matrix. I could have used matrix B. See, I could have used any one of these entries, but I edited matrix A. All right, so we return to the home screen. Now you want to put the matrix into reduced row echelon form. The way we do that is we'll access the matrix menu by doing second, the matrix button. Scroll over to the math capabilities, and I'm going to go all the way down until I see RREF. That stands for Reduced Row Echelon Form. Okay, and now it's asking for me to put a matrix in there, so I'm going to go to second, hit the matrix button, and that first one is highlighted. If you had edited any of the other matrices, you can plop it in there, but I edited matrix A, so I'm going to hit enter, and it plops it right in there. Let's go ahead and close the parentheses. Now when I hit enter, my calculator is going to perform all the operations to construct the reduced row echelon form of the matrix A. There it is. All right, so now here's what I have. Well, what we need to do now is to translate this matrix back into 3 equations so that we can understand what this means. The first row, remember these are my x's. This is my x coefficients, my y coefficients, and my z coefficients. And then we have equals the number part. This is the augmented part of the matrix. So this first row, 1, 0, 0, 3, what that says is 1x plus 0y plus 0z equals 3, i.e. x equals 3. The second row here, 0, 1, 0, -4, says 0x plus 1y plus 0z equals -4. Basically, y is equal to -4. This third row, 0, 0, 1, 1, says 0x plus 0y plus 1z equals 1. This tells me z equals 1. So we can go from the matrix back to this, the 3 equations. And usually the way that you write your answer, if you've got x, y, and z, we'll put them in ordered the coordinates. So x, y, z, usually we go in alphabetical order. So 3, -4, 1. X is 3, y is -4, z is 1.